Hi, I'm Martin Zettersten, and I'll be presenting this talk on how nameability, the ease with which something can be named, relates to subjective and objective judgments of perceptual similarity. This is joint work with Elise Suffel and Gary Lupian at UW-Madison. So the starting point for this talk is kind of a confession of love for a beautiful tool in cognitive science, uniform similarity spaces. The basic idea of these spaces is that you can create a mapping between psychological similarity and an n-dimensional space, such that the spatial distance represents perceptual similarity between stimuli evenly across the space. And a probably familiar example are color wheels within C-Lab color space, such as the one represented on the right of the current slide. Besides being undeniably lovely, I think, they also are tremendously powerful tools for probing perception and cognition. To name just a few feathers in the cap of perceptually uniform spaces, they allow for very careful control over perceptual similarity in experimental designs. And they can also be usefully deployed to ask all sorts of fine-grained questions about cognitive processes. To name just a few examples, they've been used to study precision and visual working memory and to reconstruct similarity structure in neural representations. At the same time, we also think there's good reason to be cautious when interpreting such spaces as perceptually uniform. And the key point here is that similarity can vary, sometimes quite a lot, across tasks and contexts. To give you the basic idea, here's a classic example. Imagine you're asking someone to judge whether the color gray is more similar to white or black. Considered in the context of rain and rain clouds, you might think gray is more similar to black because clouds of that color tend to both index rain. But if you consider gray in the context of age, that shifts judgments, right, more towards white, since white and gray hair, for instance, both index older age, as I've slowly begun to discover. Past work has also documented how top-down knowledge can systematically warp similarity judgments, even at pretty fine timescales in perceptual judgments. For instance, Forder and Lupian recently showed that just hearing a color name improves the discriminability of colors. In other words, the nameability of the color space appears to shift around perceptual judgments. While perceptually uniform spaces are probably best known and studied in the color domain, a recent beautiful study created a circular space for shapes. This is work by Aidan Lee and colleagues. And this space was normed based on subjective similarity. So the similarity space was created by asking participants to make unspeeded pairwise ratings of similarity. And this resulted in a space that continuously morphs between discrete shapes, with shapes equated for perceptual similarity based on those ratings. And if you have more questions about their exact norming procedure, feel free to ask in the Q&A. Great, and so now we can stare at this mesmerizing GIF for a moment to appreciate just how precise and smooth the constructed shape space is. All right, lovely. So for the current experiments, our question was whether this shape space would be influenced by top-down knowledge about individual shapes in analogous fashion to the color spaces that we talked about before. In particular, we asked whether nameability, how easily and consistently shapes could be named, would shift judgments of perceptual similarity across different tasks. We were interested in nameability due to past work showing that language can be a particularly powerful top-down cue. I'll say a bit more about why nameability may be having the effects we see here later on in the talk. So in a first step, we wanted to see how people would group these shapes that were designed to be perceptually equidistant. So we asked 28 participants to group shapes based on visual similarity. What we did is we selected a subset of shapes spaced evenly across the stimulus space, and we did that just to have a tractable number of items. We also asked participants to label each of their clusters after they sorted the 36 shapes. And we then computed mutoid-based clusters and used those to compute how likely any two items were to be clustered together across all of participants' sorts. So next I'll just show you a few examples of how participants sorted the shapes. So here's a participant who sorted the shapes into 4 groups: round and straight, shield, polygon, diamond, or stars. And this participant had 5 or 6 groups, which is also roughly the average for participants as on the whole. At the same time, we also collected nameability ratings for each shape from a separate group of participants, since we were interested in whether nameability would predict participants' judgments. And we collected these ratings by having participants name each shape using a couple of words. And nameability was then computed using Simpson's diversity index. In this index, lower values indicate lower name agreement or consistency, and higher values indicate higher name agreement or consistency. So to make this more concrete, say that we have 5 responses for one shape. Say 3 people called this shape rabbit, and 2 other people described it as bib, and another shape with a more diverse set of responses. So the first shape with more consistent responses would get a higher diversity index of 0.4. And the shape with less consistent, more diverse responses would score lower, 0.1. Great, and so we collected naming data from 115 participants. And if we just plot the distribution of nameability across the circular shape space, we can see that it turns out that there actually was quite a bit of variability in how nameable shapes were. In other words, in how consistently they were named. Okay, so now the first nameability measure that I showed you was for individual shapes. And our second measure was intended to capture the similarity in naming of pairs of shapes. For this, we counted up how often each unique token occurred within people's responses for a given shape. We stored those word counts in a vector, and then computed the similarity between vectors for pairs of shapes, specifically the cosine similarity between those vectors. So here I'm showing you an example of what this would look like for 2 example shapes and word counts. These would be pretty similar in this case. Okay, so what might one hypothesize to happen if nameability influences shape groupings? Well, if the perceptual distance of shapes is perceived as uniform across a circular shape space, then the null hypothesis would be that shapes that are equidistant, like these shapes here that are 30 degrees apart, shapes that are equidistant along the shape circle should be equally likely to be grouped together. On the other hand, if nameability influences sorting behavior, we should expect shapes with higher naming similarity to be more likely to be grouped together, since they are activating similar verbal labels. So here are the 2 shapes on the right. Both are more strongly associated with the label rabbit, and so they activate similar verbal labels, and thus would be more likely to be grouped together. And what we find is that name-based similarity, which I'm showing here on the x-axis, is in fact strongly related to the probability of shapes being clustered together, which I'm showing here on the y-axis. And this is after controlling for angular distance in the shape space. So the facets on the plot here show the relationship between naming similarity and grouping likelihood at different angular distances. Another piece of evidence that verbal information is influencing participants' sorting behavior is that the nameability of the individual shapes is also strongly related to the nameability of the clusters that they get sorted into. So shapes that are more consistently labeled on an individual level are also more likely to be clustered in groups that themselves are more consistently named across all of the participants who sorted these shapes. Great, so next we wanted to ask whether nameability predicted not just participants' subjective similarity judgments, but also a more objective measure of perceptual similarity. So to address this question, we conducted a speeded perceptual discriminability task. We collected data from 58 participants, and these participants were presented with a speeded match to sample task in which they were shown a shape and asked to find its matching target shape in the presence of a foil, and try to do that as quickly as possible. Participants were randomly assigned to judge items at 10, 20, or 30 degree distances. And just to give you a sense of how difficult the task is at these different distances, here are some example shapes at 10, 20, and 30 degree distances. And as you can see, the 10 degree difference is quite difficult to detect. That's quite subtle, but even the higher distances are not entirely trivial, right? So next, I'll give you an overview over how a match to sample trial would work. So at the beginning of a given trial, we briefly cue the shape locations, and then we presented the standard shape for 1 second, followed by the target and foil shapes. And participants were tasked with finding the shape that matched the standard as quickly as possible, and those shapes remained visible until the participant responded. So if nameability affects participants' objective judgments, we hypothesize that this would have two consequences. First, more nameable standards, and by the way, therefore also targets, would ease discriminability, since they would be more likely to activate a verbal cue. And that verbal cue, in turn, should help participants respond faster in finding the target. And what we find is that standard nameability does in fact predict faster reaction times, such that more nameable targets are found more quickly, again controlling for angular distance. And I'll just mention here that reaction times here are for correct responses only. All right, so that was hypothesis one. The second hypothesis is that this main effect should also interact with the naming similarity of the two choice options, the target and the foil. Why might this be? Well, if the target and the foil have lower naming similarity, say the target tends to activate labels like rabbit, and the foil tends to activate very different labels like blob, then activating the label for the standard should be a particularly useful cue and speed participant judgments, since there's little overlap with the verbal information associated with the foil. Conversely, if the target and foil have very similar names, say they both tend to activate labels like rabbit, then the benefit of activating the name of the standard should be attenuated. Activating the standard's label should be less helpful if it's associated with both the target and the foil. And what we see in the results for the current experiment is that, well, first, there's an overall effect of naming similarity, such that reaction times are slowed when the target and foil have more similar names, suggesting that verbal information is having an impact there. And this, again, is even after controlling for angular distance. And second, there's an interaction between naming similarity and how nameable the standard is. The less the target and foil overlap in their naming similarity, moving more to the left on the graph shown here, the stronger the effect of nameability of the standard, the more helpful that verbal cue from nameable standards is. All right, so to conclude, I'm just going to briefly sum up the main takeaways from these studies and end with some speculation about why nameability is predictive in these tasks. So the two experiments I've shown you provide further evidence that even carefully validated similarity spaces, in this case of shapes, show task-based differences and are likely sensitive to top-down information. Nameability predicted both how participants clustered shapes and the ease with which they could discriminate shapes under speeded conditions. And this was over and above what might be predicted from distance in the uniform shape space alone. So an open question from this work is, well, why? Why exactly is nameability relating to measures of perceptual similarity? So one possibility is that nameability is actually a proxy for something else that just happens to explain how participants clump together different shapes across task contexts. So perhaps related to familiarity or ease of visual encoding or some other category information. On the other hand, the way I've motivated the predictions throughout most of the talk is in line with a second possibility, that nameability is predicted because, in line with other recent evidence from this and other labs, because language provides top-down cues that can influence perceptual judgments. So the idea that labels may act as guides in perceptual judgments, of course, has a long history in psychology. Since this work was done in a lab that has Sapir in its lab website name, I kind of have to mention that similar ideas were posed pithily by Edward Sapir. For example, in this quote, where he said that even comparatively simple acts of perception are very much more at the mercy of the social patterns called words than we might suppose. Now, since we did not causally manipulate nameability in the current experiments, the conclusions that can be drawn about whether these effects are truly about verbal labels per se are limited. Currently, we're considering two possible extensions of this work that could be more informative about whether these effects are really about language. One possible direction is to manipulate verbal information directly by up or down regulating verbal cues during these judgments. Another possible direction is to look at cross-linguistic variability. And the idea here is that different languages will probably carve up the shape space used here differently. And we could test whether this pushes around effects of perceptual similarity across the shape space. All right, so with that hint towards future work in this area, I'd like to end by thanking the Lupien Lab team for their support throughout this project and our funding. And please feel free to reach out to me with questions or comments. Thanks.